Hello and welcome to this video. In this video I will show you how to create a multiplayer game in Unity 6. It will be a simple 2D game and it will not be so fun of a game or good looking, but we will learn a lot of the multiplayer concepts and how to make a multiplayer game. Let's get started. Okay, so we've got a new Unity project and we start by clicking on Package Manager and Unity Registry to install the netcode for game objects package. If you scroll down and search for the netcode for game objects, I'm sure you will find it. Then we click install on this package and wait for it to install. And then, since we also want to be able to test our multiplayer game in multiple windows, we install the multiplayer play mode, and I will show you that in a second. So install the multiplayer play mode package as well. So when that is installed, we can click on Window and Multiplayer Play Mode to open a new window called Multiplayer Play Mode and drag and drop it here beside the animation. Then we can add more virtual players. So we can click this Player 2 checkbox to add another player to it and wait for it to activate. And then we can see that when we debug our game, we can have Player 2 in a separate window. And this makes it a lot easier to debug our multiplayer game. So next thing we need to do is create the network manager. So create a new empty game object called network manager and add component called network manager to it. Then in the select transport dropdown, we select the Unity transport. We might change this later, but we go with Unity for now. And now let's create our first script. So create a new folder called scripts, double click it and create a new monobehavior script called player movement. And double click it to open it in your favorite code editor. And then we create all the basic fields for a player movement. So just a rigid body 2D, a float for move horizontal and move vertical. We have the move speed and a vector 2 to hold the movement. And this will just be a basic movement script, nothing special, and we might be able to make a better movement script, but this tutorial is not about player movement, it's more about multiplayer. So I'll just set up this basic movement for now. In the start function, we set RB to get component rigid body 2D, of course. And then to be able to use the netcode multiplayer stuff, we will remove this mono behavior and inherit from network behavior instead. So then in our update function, let's create a void update. Then we can now check if the player is the owner of the script. So if we are not the owner, we just return out. So when we're playing this multiplayer game, we can only control our own player and not the other players, of course. And change update to fixed update for the movement and call the move function that we will create now. So void move. We set move horizontal equals to input.getAxis horizontal and move vertical equals to input.getAxis vertical. And then we set movement equals to a new vector 2 of move horizontal and move vertical dot normalized. And finally, we set the rb.linear velocity equals to movement times move speed. So that should be it for a basic movement script with the old input system. So as I said, it's just a tutorial about multiplayer and not about movement. So that's the basic player movement script. So now to set up our player, we create a new 2D circle called player and add the player movement script to it. So add component, player movement, and then we'll see a network object gets added to it as well. It's because we use network behavior instead of mono behavior. Then we get a network object component, because all objects that will be synced across the network needs a network object on it. And we also add a rigid body 2D and set gravity scale to 0, since we want this top-down movement. Then we create a new folder called prefabs. To make a prefab out of the player, we drag and drop it into the prefabs folder and delete it from the scene. First we can just press play, and we will see we will not be able to move him just yet, because it needs to be spawned on the network for our network player movement script to work, since we call this, we check if is owner. So if we comment that out and press play again, then we'll see that we can move this player around. So the movement script works, and that's great. But since it will be a multiplayer game, we need this. If we are not the owner, we return out of the update function. So let's make it so we can spawn this player when we join the game. And in the network manager, we can see that we have this default player prefab field. That's where we will drag and drop the player prefab onto, and then we can delete it from the scene and press play. So if we press play and select network manager from the hierarchy, and in the inspector we click start host, we see that our player gets spawned and we can actually move it around. Awesome. And you have to click the don't destroy on load on the left to be able to see this network manager if you don't find it in the hierarchy. And now we can also see that because we have the multiplayer play mode, we can actually press play and see on the second window pretty much the same thing. If we click layout and select hierarchy and inspector, we can see those things in the multiplayer debug second window as well. So we can press start host on the right and start client on the left, and we can see that now we can move on both windows to debug our multiplayer game. But we can see it's not synchronized over the network. And to fix that, we need to add a network transform. So on the player prefab, we go to add component and search for network transform, which is a part of the netcode for game objects. We untick all the values we don't need, and we only need X and Y position to be synced. We set authority mode to owner and not server. And this warning says that we want a network rigid body 2D as well. So let's add that. So this will be just a client authoritative way of moving the player. And now if we press play and start host on the right, and on the left we press start client in the network manager, we can see that it's now synced across the network. So when I move on the right, it moves on the left as well. And when we move on the left, it moves on the right as well. Perfect. And now we want the player name to be shown above the player. So to fix that, we will go into the player prefab. and create a new game object on it. So right click, create empty, call it name or player name or something. Then we click add component and select the text mesh pro text. So make sure you take the one that says text only and import TMP essentials. So let's just add a basic name or default name. We set it to unknown and make it centered. And we can see it's very big right now compared to the player. So we scale it down a little, set the font size to something like 12, maybe 8. Scale it down a bit more and position it wherever you want. I will put it right above the player. And that's good for now. So now if we press play to test the game and select the network manager, press start host, we will see that the name is above the player all the time, and that's exactly what we want. Now if we want to speed it up a little so we can debug it faster, we can go into project settings, click editor, and under enter play mode settings we can select do not reload domain or scene, and then when we press play after that it will load a lot faster. So that's what I like to do. And now it's time to create some user interface. So let's go into script and create a new monobehavior script called player name. And open it up as usual. And this player name should be synced across the network. So if a player sets a name, it should everyone should see the name that he has chosen. So we create a new field called player name of type text mesh pro. Make sure you write serialized field so you can assign it in the inspector. And then we will create a new network variable. So public network variable, fixed string 32 bytes is the type. I call it network player name. Set it equals to new network variable, fixed string 32 bytes, and a default value of unknown. And then for the second parameter, which is the network variable read permission, we set it to everyone. And the third is network variable write permission and set it to owner. And that is just to select who can read or write to this network variable. So the first parameter is the default, which is unknown, and the second is the read permission, and the third is the write permission. Then we will set an event called onNameChanged. So if we change name, we also want to sync it across the network. We override on network spawn, and to do that we need to change mono behavior to a network behavior, which we should do anyway. Then we can override the on network spawn method, which happens every time this game object gets spawned, of course, which will be when we join the game. So we check if we are the owner of the script. We check the input name, so string input name equals to find first object by type. And here we will pass the type UI manager, which we haven't created yet. And the input name will be the player input, so you can use to type your name. And on that we will call the name input field dot text to get the name that the player has typed. Then we check, or we set network player name dot value equals to a new fixed string of 32 bytes and pass the input name. Then we set player name dot text equals to network player name dot value dot toString. and network player name dot on value changed, we will subscribe to a new method called network player name underscore on value changed. And then we just invoke the action that we created above. So on name changed, invoke network player name dot value dot toString. And then we create a new method that will be called when the name gets changed. So we create a private void network player name underscore on value changed, which takes two parameters. It's the previous value and the new value, and both of types fixed string 32 bytes, which is the type that we can pass across the network. And inside this function, we set the player name.text equals to new value.value and on name changed dot invoke with the new value.value. And then we make a get method for this player name, so public string get player name, and return the network player name.value.toString, so we can access it from other scripts as well. Awesome. Now let's create the new script UI Manager, which will be responsible for the network menu and the name input and stuff like that. So we'll create some buttons to join and host the game. So create a new serialized field, public TMP underscore input field called name input field, and another serialized field, private text mesh pro GUI called game info text, another serialized field of type button called host button, and the same again, a button join button, and another serialized field of type game object menu, which will be the full game object that we can toggle on and off. So in the start function, we set host button.onClick.add listener and pass a method called host later, and do the same for the join button, but we will pass the join method. So pass host and pass join. Then let's create these functions, host and join. And inside the host function, we set network manager.singleton.startHost, which is the same as starting the host from the network manager that we did before. And then we set the menu to inactive or menu.setActive false to hide it when we are playing, and set the game info text to we set it to active. So game info text.gameObject.setActive true, and game info text.text equals to press enter to start. And almost the same for the join, we set network manager singleton.startClient instead of start host, menu.setActive false to hide the menu, game info text.gameObject.setActive true, and we set the game info text.text to waiting for host. So only when the host presses enter, the game will start. So now we have what we need in the UI manager, which we access from the player name script. So everything should work. We would get rid of the errors. Awesome. So now let's create a new game object called UI Manager so we can attach the script to it. Then we need to set up all the UI fields. So we start with a panel called menu, which will be the menu that we toggle on and off. I will resize it, and you can pretty much size it however you want or do it as you prefer. I'm not going to make it very pretty. I'm just, as I've said earlier, it's a tutorial about multiplayer networking and not about UI. So let's set up the buttons. A host button, position it wherever you want, make it bigger if you want, and change the text to host. I will increase the font size a little and then duplicate the host button to make a join button, which will look the same, but it will say join instead of host, and we will position it below the host button. And then we need the input field to enter our name, so we call it name input field. Drag it to the top if you want, position it, and set the placeholder to enter name or something like that. Make it a little bigger, and I will center it vertically. Now we will also add a UI text for the game info text and position it at the top or wherever you want. I will make it centered. Okay, so now we can assign these fields into their assign the objects onto the fields, host button, join button, the whole menu to the menu field, the game info text, and the name input field. Perfect. Now we can press play, and okay, the text there was a little small, and it's not working to set name. So let's figure out what's wrong. So first of all, we can increase the font size of the text in the input. And then, of course, on the player game object prefab, we need to add the player name script and open the prefab and drag and drop the name onto the player name field in the player name script. And we can set the tag of the player to player and go back. And then when we press play and enter a name, I will enter the name hello for the host, move it around a little bit, and for the client, I will say player 2, join, and we can see that the names are synced across the network, and that is awesome. We can see it says waiting for host and press enter to start on the game info text. So everything seems to be working. Very nice. Now let's create a way for our players to get some score. So let's make it so every time they pick a coin, they get a score. So create a new 2D circle called coin and make it like yellow so it looks like a coin. Then, as you remember, all the networked objects need a network object script. So let's add a network object to it. Then we also add a rigid body 2D with no gravity, so we can collide with it, and of course a circle collider 2D as well. And set it to isTrigger, of course. Then we make a new script called coin. Inside the coin script, we make a new serialized field called coin value, so we can decide how many points each coin are worth. And we set void on trigger enter 2D, collider 2D other, so to see what happens when we collide with it. So we say if other.compare tag player, meaning the coin collides with the player. Then we get the player ID from the player that collided with us. So ulong player ID equals other.getComponent network object dot owner client ID. And owner client ID is always a ulong. That's why we use that type. And then we create a new RPC send to server, public void destroy coin RPC. and inside of that we call getComponent network object.despawn and pass true, and then we destroy the game object. So this RPC is just so we remove the coin for all players when one player collides with it. Then we make sure the coin script is assigned to the coin game object. We have the coin value 1. And let's just duplicate the coin to see if we can pick them up. Let's make a new host and make a client, give them names, and nothing happens when we try to collide with it. So I think we don't even have a collider on the player object. So open the player prefab and press add component to add a circle collider 2D to it. And if we check the coin script, we see that we're not even calling the RPC. So we have to call destroy coin RPC inside the onTrigger enter 2D method. Then we also want to make sure in the rigid body 2D on the player that we freeze the rotation, so under constraints. And let's test it again. We host and we join and we try to collide with the coin, and it says only the server can despawn objects. So the reason for that is that we forgot in the coin script to inherit from network behavior instead of mono behavior. So the RPC didn't work. So let's inherit from network behavior and save the script and try again, and we should be good to go. We make a host, we make a client, we pick a coin, and it gets removed from both the server and the client. Perfect. So now we need some kind of scoreboard to display the players' scores, so we can see which player that picks up the most coins. So create a new C# script called Scoreboard Manager. And another monobehavior C# script called Scoreboard UI. And inside the Scoreboard UI script, we need a serialized field, game object, player entry prefab, and a public static scoreboard UI instance. So using the singleton pattern, we will be able to access the instance from other scripts. And we will set a private dictionary with types ulong and player entry, which we haven't created yet. Call the dictionary player entries and set it equals to new dictionary ulong and player entry. And we create the player entry script. Create monobehavior script, call it player entry. And in the player entry script, we need a field for the player name and a field for player's score. So make them serialized fields so we can set it in the inspector and of type TextMeshPro UGUI, remember. So we say player name and player score, and we make a method to set it. So public void set player entry, pass the string name and the int score, set player name.text equals name and player score.text equals score.toString. So this dictionary in the Scoreboard UI will be of this type, player entry, that we just created. And now we create the awake method and say if instance equals null, we set instance equals this, and else we destroy the game object following the singleton pattern. Then we create a new public method called update scoreboard and pass a list of player stats to it, which is another script we haven't created yet. So let's do that. Create monobehavior script, call it player stats. And the player stats will hold the stats for every player, of course, and keep it synced across the network. Instead of inheriting from monobehavior, we'll inherit from network serializable to keep it serializable over the network, and also inherit from equatable, or I'm not sure how to pronounce that, but use the player stats as type for it. Then we create the equals method and the network serialize method. We can press Ctrl dot to make the editor create the functions for us. And in the network serialize method, we call serializer.serializeValue, pass ref player ID, which we haven't created yet, so create the field public ulong player ID, and another field public int score. So serializeValue ref player ID and serializer.serializeValue ref score. And for the equals, we just say a return player ID equals other.player ID. So that's how we compare it. And that's it for the player stats script. Let's go back to Scoreboard UI and say for each var player in player list, we get the player name equals unknown. And if network manager.singleton.connectedClients.try get value and pass player.player ID, and then we say out var client, and client.player object is not equals null. Just clean the code up a little, so we make a new line here. So what happens is that we try to get the value player.player ID in the connected clients. So if we have a connected client with this ID, then we out that client. So we can use the client.player object. So then we can check if client.player object.try get component and out player name. So we check if the player name script is on this client player object. If so, we set player name equals to player name component dot get player name that we created earlier. And then we say player name component dot on name changed plus equals. So we subscribe to it, name arrow function update player entry, and pass the player ID, we pass the name, and we pass the player score. And below this check, we also call this update player entry method. And we create the new update player entry method here, which takes ulong for player ID, the player name, and the score. Inside this update player entry method, we say if player entries.try get value player ID and out var entry, then game object player entry object equals instantiate player entry prefab and pass the transform as position. And then we say entry equals player entry object dot get component of type player entry, and player entries at position player ID that we passed equals entry, and then we set the name on the entry. Okay, that's a lot of words, but that's it for the Scoreboard UI script. Now let's fix the Scoreboard manager. First of all, we will use the singleton pattern again to make an instance of Scoreboard Manager so we can access it from other scripts. We change monobehavior to network behavior, and we make a public static Scoreboard Manager instance, get and private set. Then we make a private network list of type player stats. Call it network player list equals a new network list, player stats. In the awake function, as usual, we check if instance equals to null. We set instance equals this, and otherwise we destroy the game object. This way we make sure there's only one instance. Then we set network player list dot on list changed equals to, or not equals to, it's more like we subscribe to on player list changed method that we will create now. Private void on player list changed, network list event, player stats, call it change event. So this is the event that is passed when on player list changed happens. So list player stats, call it player list equals new list of player stats. Then we check for each var player in the network player list. We add the player to the player list. So we keep this local player list updated as well. And we call scoreboard UI.instance.update scoreboard and pass the player list. So we don't pass the networked player list, we only pass the local player list, which we create out of the network player list. Then the next function, we will just override the onNetwork spawn method again, as we did before. And whenever the scoreboard manager is spawned, we check if we are the server. So we are only the host, or actually only the server will subscribe to this. So network manager.singleton.onClient connected callback plus equals handle player connected, which means, or which will trigger every time a new player connects. So handle player connected is the method, and inside it we say player stats new player equals new player stats. So whenever a new player connects, we set player ID to the player ID of the connected player and score to 0, because we start with 0 score, and then we add the new player to the network player list. Then we need to create a method to increase the score, and it will be a server RPC. So RPC send to server, public void increase player score RPC, pass the ulong player ID, and pass the int of how much score we want to increase. Then we make a basic for loop that loops through the network player list. And we check if network player list I.player ID equals the player ID that we pass. We set var player equals network player list I, and that is the player that we want to change the player.score to plus equals the score increase that we pass to the method, and network player list I equals to player, and then we can break. So that method only handles the increased score of the player. Then we create a new method called getWinnerName to calculate who won the game. And that method will check if player list count is equals to 0, we return no players. And otherwise we create a player stats top player equals new or equals network player list and pass 0 as index, and check for each var player in a network player list. We check if player.score is greater than the top player.score, then we set the top player to this player. So this way we loop through all the players to see which one has the highest score and set that one to the top player variable that we created. And then when we have found out who is the top player, we check if network manager.singleton.connectedClients and try get value top player.player ID and out var client. So we check if there is a player with this ID in the connected clients list, and if client.player object is not equals null, and client.playerObject try get component player name. So we check if it has the player name component as well. If so, we return a string which says player name component.get player name 1, because we use the player name component to see the name of the player. And if we don't find that component, we just say unknown player 1, because then we don't know the name of the player. And up here we have an error that says player stats needs to be a value type. So we have to make the player stats a struct instead of a class. So public struct player stats. And if we now save all the scripts, Scoreboard Manager and Scoreboard UI, we should get rid of all the errors. So now it's time to get back to the editor to create the Scoreboard UI and a game object for the Scoreboard Manager. So create empty game object called Scoreboard Manager and attach the script Scoreboard Manager to it. And then inside our canvas, we create a new empty game object called Scoreboard UI. We add the component to it, Scoreboard UI, and we align it to the left or wherever we want to show the scoreboard. We resize it however we want. And then we add a new component to it. And we add the vertical layout group to lay out each player name and the score. We set child force expand to width only and not height. We set the padding to 24. We align it upper left. And we create a new empty game object inside it called player entry. So this will be our player entry prefab. And inside the player entry, we add a new game object called name text. We set the size to fill the whole width of the object or of the parent object. Increase the width on the name text to match the parent. And on the name text inside the player entry, we add a new component called TextMesh Pro Text UI. Then we can test write something like player 1 to see what it looks like. Because this is what it will look like in the scoreboard later. We add another text called score text, like duplicate the name text and call it score text and set it to 0, because this is where the score will be displayed. Then on the player entry parent, we add the script player entry and drag and drop the name and score onto the matching fields. Then we can test to duplicate the player entry a lot to see how they line up. And it looks pretty good to me. So we can drag and drop the player entry into the prefabs to make a prefab out of it and remove it from the scene. Then we drag and drop the player entry prefab onto the Scoreboard UI field that takes the player entry. And we can test the game. So when we join, we see, okay, it says Scoreboard UI, which is something wrong. I think we use name in the script somewhere. So we have to check the script and scroll down. Yeah, right here in the update player entry, we see that we take a parameter called player name. And that is what we want to pass into the set player entry instead of just name, because name will be the name of the game object that the script is attached to, like Scoreboard UI. But now when we pass the player name instead of just name, we will get the actual name of the player, hopefully. Yeah, in the scoreboard now we see hello, and when the client joins, called second. Awesome, it works. So we have a hello and we have second in the list. So now to update the text or the player score text in the Scoreboard Manager, we go into the Scoreboard Manager and where we say increase player score RPC, you can use the instance of the scoreboard manager and go into the coin script, and when we collide with a player, we call scoreboard manager.instance.increase player score RPC and pass 1 if we want the coin to add 1 score. And also we need to pass the player ID first. So first player ID and then 1 to set which player that will get 1 score. And now if we press play and test the game, we should see the score increase when we pick a coin. And it does. Perfect. So what is left to do now is to make the host press enter to start the game and have some kind of timer, so to see which player that picks the most coin within a certain amount of time, and make the coins spawn at some random positions. So we create a new game manager, or a script called game manager, and create a new serialized field in it of type text mesh pro UGUI as before, called game info text, and a public static game manager instance get private set to make a singleton out of it. And then we create a private network variable of type float, called game time equals new network variable of type float. Set 10F as default. This will be like the countdown timer. So each round is 10 seconds. Then we need a private bool for game active equals false to see if we are playing or not. And we need another serialized field for the coin object. So game object coin prefab. And we need a serialized field private vector2 spawn area min and spawn area max. This is to decide like where on the game the coins should be able to spawn. So like the area where they can be spawned. Then we also need a serialized field for the spawn interval. So how often the coins will spawn. We set it to 1 second as default. So every second we will spawn a new coin. And in the awake function, as usual, we set instance equals to null. Or we check if instance equals to null, we set instance to this, or else we destroy the game object. And then we create a start function, which happens after awake. So void start, and we can set the game info text here. Dot text equals to press enter to start. Like the host will press enter to start the game. And game time dot on value changed will subscribe to update game info text. So we create the update game info text function. Void update game info text, float previous time and float new time. And we check if game is active. We set game info text dot text equals to the new time, and format it like this with colon F1 to C1 decimal of the float. And in the update function, we check if is host, so if we are the player who hosted the game, and also make sure we inherit from network behavior and not mono behavior. So if we are the host and input.getKeyDown key code return to see if enter is pressed and the game is not already active, of course, then we start the game and create a new start game method soon. If we are not the server or the game is not active, we return out of the function here. Otherwise, we set the game time.value minus equals time.delta time, so we make it go down every second. And if game time.value is less than or equals to 0, we end the game. So we create the start game function, void start game, and it will start the game for us. We check if we are not the server, we return already. We debug.log game started. We set the game time.value equals to 10f for now, just because that's the default time we want. When we start a new game, it will count down from 10, and we set the game active RPC to true, which we'll create soon. And then we invoke repeating name of spawn coin and pass 0 and then spawn interval. This will make the coin spawn every second after we have created a spawn coin method, of course. But first, or actually we do it now. So we create the RPC, send it to clients and host, void set game active RPC, and take a bool active. And in here we set game active equals active and game info text.text equals to active, or if active, we set it to game time.value formatted :F1, and if it's not active, we say game over in the game info text. Then we create the private void spawn coin method, which will check if game is not active, we return. Otherwise, vector2 random position equals new vector2, where we pass the spawn area min, or a random.range of spawn area min.x and spawn area max.x. So we get a random x value between the min and the max, or x values that we set, and we don't want to use the system, so remove using system from here. So we use the Unity engine.random. And the second parameter in the vector2 will be a random.range of spawn area min.y and spawn area max.y. So this will be the spawn area. A random place in the spawn area is where the coin will be spawned. And now we set a game object coin instance equals to instantiate a coin prefab at the random position and quaternion.identity as rotation, since we want no rotation on it. Then var network object equals coin instance.get component network object to get the network object of the coin. And if we find the network object, so it's not equals null, then we can say network object.spawn. That's how we spawn it on the network. So now we need to create the endgame function, so private void endgame. We set gametime.value equals to 0 to not get below that, and we set gameActive RPC to false to set gameActive to false, and we cancel invoke of the spawn coin method. Then we make a list of coins and find all coins in the scene to destroy them. So an array of coins equals to find objects by type coin with no sort mode, and just loop through them. For each coin in coins, we call coin.destroy, or actually destroy coin RPC, because we need to destroy them on the network. So this is the destroy coin RPC inside of the coin script that we created earlier. And then we want to update the text for all players to see who the winner is. So we make a new RPC called update winner, or update winner RPC. And we set the attribute RPC send to clients and host to update it for everyone. Call the method void update winner RPC. And inside of here, we just get the winner text. So string winner text equals scoreboard manager.instance.get winner name. And set game info text.text equals winner text. So now we can save all the scripts and give it a try. If we press play now, we will see if we forgot anything. We enter a name called hello, we enter a client called hi, and we see that it says press enter to start. Actually, we forgot to remove the coins from the scene. So we make a prefab of the coin. We remove the coins from the scene. We create a new empty game object called game manager. We add the game manager script to it, and we assign the game info text to the correct field. We assign the coin prefab to the coin prefab field, and to decide the spawn area min and spawn area max, we can just increase the camera a little bit. I will set the size to 12 on the main camera, and I will add a coin to the scene and position it where I want the min position to be. So it looks like -20x and -11y. So we set spawn area min to -20 for x and -11 for y. And it should just be the opposite for the max, but we can drag it over here to see that, okay, 20 and 11 will be the max. So, okay, we set max to 20 for x and 11y, and remove the coin again. And that's pretty much it. If we press play now and enter a name called test, and the client can be called CCC, we can see that when we press enter as the host, the game starts and runs for 10 seconds, and the player with the most coins at the end wins the game. Let me know in the comments if you want to see me animate or add some graphics to this, or anything else, add sounds, or just let me know in the comments if you want to see a follow-up or a part 2 of this, and tell me what to do, and I will see if I can do it for you. Thank you for watching. Leave a like and subscribe if you want. Goodbye.